So, now we are moving to the another question, that is question number 53. So, question number 53 is on your screen. A button cell used in watches function as following. They given this one reaction. If half cell potentials are, they given the half cell potential also, and they ask you the cell potential will be. So, this question is come from your electrochemistry chapter of your class 12 NCERT. So, now we are moving to the solution part. So, let us first calculate the oxidation state of this. Okay. Now, for zinc it will be 0 and it will be converted into a +2 state, means this process is your oxidation process. Now, for this Az it will be 2x plus or minus 2 is equal to 0. So, it will be end up with 2x equal to 2, x is equal to +1. So, here for this Az it will be +1 and here it will be 0. So, this process is known as reduction process. Now, which formula we are going to use here? We know E cell is equal to E standard reduction potential. SRP is nothing but standard reduction potential of cathode minus E standard reduction potential of your anode. Now, if you see in this reaction they are giving your E values. Okay. Now, see for this +2 is converted into 0, means they already given your standard reduction potential, and if you see this process means we know anode, bridge, cathode. Okay. So, this is the cell representation, right, anode, bridge and cathode. So, this is your cell representation. Now, if you see here anodic value, anode it will be take place as oxidation. Now, which undergoing oxidation, this process is going under oxidation, means this process is undergo oxidation. Now, they giving the reduction potential value. Okay. So, E cathode and E anode. So, this value is nothing but this is your E anodic value, E anode of standard reduction potential. Okay. Now, for another reaction, this is in cathode. Cathode, what will happen? The reduction process will take place. Now, if you see the following reaction, which is known as the reduction process, this is a reduction reaction, means this is a reduction reaction and they give you the value of reduction potential as 0.34. So, this is nothing but this is E reduction SRP, that is standard reduction potential of your cathode. Okay. So, now what you are getting, that is 0.34 minus, and what is the value of anode they are given standard reduction potential, it is given as minus 0.76, minus 0.76. Now, this should be minus minus, it should be plus. So, 0.34 plus 0.76. Now, if you are solving this one, that is 6 plus 4, it will be coming as 10, 1 and it will be end up with 1.10. Now, if you see in option number 1, it is given as 1.10 volt and this is the correct answer of your question number 53. So, now we are moving to the another question, that is question number 54. So, question number 54 is on your screen. How many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar nitric acid? The concentrated acid is 70% nitric acid. So, this question is come from your very first chapter, that is the some basic concept from your class 11 NCERT. So, now we are moving to the solution part. So, they ask you how many grams, like we have to find out the weight. Okay. So, before that we know they giving the molarity formula. So, what is the molarity formula? M is equal to given weight divided by the molecular weight into 1000 divide into VML. Okay. So, this formula we are going to use to find out the weight. Okay. Now here they are giving us 2 molar. So M is 2. What is the weight of nitric acid? We have to find it out into 1000. What is the molecular weight of nitric acid? Okay. For this you have to find out 1. For nitrogen it will be 40. For this one 16 into 3 48. So means 8 9. So if you see the molecular weight of nitric acid, it will be like for hydrogen 1, for nitrogen 14, and for oxygen, that is O3, it will be 48. Now if you do the calculation, that is 4 plus 1, that is 5, 5 plus 8, that is 8, 9, 10, 11, 12, 13, 1, that is 2, 4, 5, 6, yeah, 63. So 63 is the molecular weight, and what is the ml they are given is 250 ml. So 250. Okay. So now just do the calculation here. W is equal to 2 into 63 into 250 divided by 100. Okay, sorry, 1000. This one will be cancel out. 25 into 4, 2 into 4, that is 2, that is it will be coming as 31.5. So W it will be end up with 31.5 gram, but this is not, like they are given us concentrated acid is 70%. Okay, 7. What does it mean? Like 70 gram it will be present in 100 gram solution. Okay, 70 gram of nitric acid. So 70 gram of nitric acid is present in 100 gram of solution. So 31.5 gram present in. So now we have to find it out in 100 into 31.5 divided by 70. Okay. So let's do the calculation, like 100 into 31.5 divided by your 70, and it will be end up with like 77 and 31.5, that is your 315 by 7, it will be end up with 4, that is 28, it will be 45, wait, 315, yes. So it will be coming as 45 gram. Okay. Now if you see how much it will be coming as 45 gram of nitric acid it will be present. Now if you see in option number 1 only given as 45 gram. Okay. So option number 1 is the correct answer of your question number 54. So now we are moving to the another question, that is question number 55. So question number 55 is on your screen. The number of carbon atoms per unit cell of your diamond unit cell is. So this question is come from your solid state chapter of your class 12 NCERT. So now we are moving to the solution part. Now they give you the diamond unit cell. So in diamond unit cell, okay, diamond. So first we have to know the locations of your atoms. So the location of your atom, that is present in at all corners plus at FCC plus half of your tetrahedral voids. Now the location of your tetrahedral void is important. Okay. So it will be present in 2 in each body diagonal. Mean in one body diagonal there is a 2 tetrahedral void is present. So how many body diagonals are there? That is 4 body diagonals is there. So 2 into 4, these are body diagonal. So it will be 8. So total tetrahedral void is 8 in number. Now at all corners it means 8 corners are there, 1 by 8, and how this 1 by 8 will come we are already discussed in theoretical part. FCC, that is 6 face is there, half, this half is also we are already discussed, half into tetrahedral void is 8. So 8 will be cancel it out, 2 it will be 3, 2, 8 it will be 4. So 1 plus 3 plus 4, and your last answer it will be end up with your 8. So 8 is the correct answer. If you see among your 4 options, option number 2, that is 8 is the correct answer of your question number 55. So now we are moving to the next question, that is question number 56. So question number 56 is on your screen. Maximum deviation from ideal gas is expected from. This question is come from your states of matter of your class 11 NCERT. So now we are moving to the solution part. Now they ask about the maximum deviation. Okay. So to find out this maximum deviation, we have to find out the where intermolecular force of attraction is more. Intermolecular force of attraction is more. Okay. Where this intermolecular force of attraction is more, there they are showing that maximum deviation. Now for which types of molecular the intermolecular force of attraction is more? Specifically the polar molecules. Okay. So polar molecules, they having the higher value of intermolecular force of attraction. If they are having a higher value of molecular force of attraction, that is intermolecular force of attraction, then they show the maximum deviation. Now if you see which one is the polar molecule here, here only one polar molecule, that is your option number 4, that is ammonia, it is a polar molecule. So it's having the higher value of intermolecular force of attraction. When they are having a higher intermolecular force of attraction, they show the maximum deviation. So option number 4 is the correct answer of question number 56. So now we are moving to the another question, that is question number 57. So question number 57 is on your screen. A metal has a FCC lattice. The edge length of the unit cell is 404 picometer. The density of the metal is 2.72 gram per centimeter cube. The molar mass of the metal is. So this question is come from your solid state chapter of your class 12 NCERT. So now we are moving to the solution part. So the formula we are going to here, that is D equal to Z mW by Na into V. So this formula we are going to use it here. Now first let us see the Z value. The Z value for here, this is given as FCC lattice. So the Z, which is called as total lattice count, the value is 4. Now V we can do this like V equal to A cube. Okay. This A is nothing but this is your edge length. And what is the value is given here? 404 picometer. Now if you see in density, it is given in centimeter cube. So this way we have to convert it into centimeter. So 404 into 10 to the power minus 10 centimeter. Now let us calculate V. A cube is nothing but 404 into 10 to the power minus 10 whole cube and centimeter cube. If I solve this one, it will be value is coming as 6.6 into 10 to the power minus 23 centimeter cube. So this value is nothing but this is the value of V. Now the D value is given as 2.72, Z value is given as 4, MW we have to calculate out. Na is nothing but 6.02 into 10 to the power 23, V value is nothing but that is 6.6 into 10 to the power minus 23. Now, MW if I am keep it here, so 2.72 into 6.02 into 10 to the power 23 into 6.6 into 10 to the power minus 23 divided by 4. Now, if you solve this part, your value nearly come 6.6, this 10 to the power 23 and this one will be cancel it out. So, 6 into 6.6, this value is completely approximately come as 27 gram per mole. Just do the simple calculation here, multiplication of these terms divided by 4, your value is approximately come as 27 gram per mole. Now, if you see among the option number 3 where 27 gram per mole is given answer, and this is the correct answer of your question number 57. So, now we are moving to the next question, that is question number 58. So, question number 58 is on your screen. Dipole induced dipole interactions are present in which of the following pairs? So, this question is come from your states of matter of your class 11 NCERT. So, now moving to the solution part. So, here they ask about dipole induced dipole. Okay. So, for this we have to need one dipole molecule and another one is induced dipole. Now, for dipole we required a polar molecule, right? The polar molecules basically having a dipole moment. Now, if you see in the options only this HCl, how this HCl? So, here it will be delta positive and delta negative. So, each having this dipole part. So, that is why this option number 3, that is HCl, it having a dipole, whereas helium it having an induced dipole, and option number 3 is the correct answer of your question number 58. So, for this only you have to find out the polar molecule or the molecules who having this dipole moment. So, now we are moving to the another question, that is question number 59. So, question number 59 is on your screen. A magnetic moment of 1.73 Bohr magneton will be shown by one among the following. So, now we are moving to the solution part. So, for that we first have to find out the oxidation state of the your d blocks elements. Like see, first one is copper is plus 2, for this one cyanide having minus 1. So, 4 minus 1 again x minus 4 equal to minus 2, and it will be end up with your plus 2. So, nickel also present in plus 2 form, for this one it will be present in plus 4 form, for this one minus 6 it will be gone on this side, that will be plus 2. So, these are the oxidation state. Now, we know Sc, E, V, Cru, Man, Fe, Co, Ni, Ku, Ja. So, we need D1 S2, okay, D1 S2, D2 S2, D3 S3, D4 S2, D5 S2, D6 S2, and we required copper, right here. So, D1 S2, D2 S2, D3 S3, D4 S2, it should be D5 S1, D5 S2, D6 S2, D7 S2, D8 S2, D9 S2, it should be D10 S1 and D10 S2. Now, we required nickel, where it will be nickel this one. So, it should be a plus 2. So, nickel plus 2 configuration it having a D8. Now, for this one copper Cu, if you see Cu, this is Cu. So, for required we required plus 2. So, if I am remove from one from here and another one from here, it should be D9 configuration. Now, another one is Ti, that is should be, and it will be plus 4. So, plus 4 if I am doing, so it will be D0, and COCl6 that is cobalt, where it is this one. So, for this we require plus 2, if I am remove plus 2 here, so it will be plus 7. Okay. So, D7. Now, for this one TiCl4 we can already neglect it out. Now, for D7 if you see 1, 2, 3, 1, 2, 3, 4 and your 5. Now, for this one that is cobalt, where it is? It is, yeah. So, this is an weak field ligand. So, weak field ligand no pairing. So, 1, 2, 3, 4, 5, 6 and 7. So, unpaired electron is, it will be 3, and when it will be 3, the Bohr n is equal to 3. What is the formula of magnetic quantity? N plus 2, n into n plus 2. What is the value of n? It will be 3, 3 plus 2, and it will be not equal to 1.73. So, your this cobalt Cl6 4 minus this one also cancel it out. Now, nickel part if you see D8. So, how it will be look like D8? Again 1, 2, 3, 4 and 5. So, 1, 2, now cyanide is a strong field ligand. So, 1, 2, 3, 4, 5, 6, 7 and 8. Now, here number of unpaired electron is 2, and 2 if I am writing as n into n plus 2, that is be 2 into 2 plus 2, that is 4, 4 into 8 1. No, this is also not equal to your 1.73. So, you have to left it out only one option, that is CuNH3 whole 4, it will be a plus 2 oxidation state. So, if I am removing this plus 1 and your ammonia is your weak field ligand. So, I am end up with 1, 2, 3, 4 and 5. So, 1, 2, 3, 4, 5, then your 1, 2, 3, 4 and 5, because weak field ligand. So, no pairing 1, 2, 3, 4, 5, 6, 7, 8, 9. So, only one unpaired electron will be there. So, n is equal to 1. So, now Bohr magneton n into n plus 2, it means 1 into 1 plus 2, that will be coming as 3, and root 3 value is 1.73. So, your option number 1 is the correct answer. Now, in the examination you no need to do the all stuff. Now, if you see the value is given as 1.73, it means the number of unpaired electrons, how many it will be there, you have to find out the number which is come before your point. So, your number of unpaired electrons is 1. So, now just check where number of unpaired electrons will be 1. Only in this option, that is first option, the number of unpaired electron is 1. So, your option will be, your option number 1 is the correct answer. Now, if unpaired electron, it will be coming as 2.5. So, definitely then the Bohr magneton value, that is mu is equal to 2.5, it means the number of unpaired electrons it will be 2. So, these things is come from your observation part, it just you can remember as a trick.